Hi learners, wish all of you a very good day. So till now we have come to know that what is control system, what are the industrial applications of control. So within this lecture, we'll be discussing about that what are the various types of the control system, and we'll be discussing about the classification of the control system in a number of ways. So first classification of the control system is based on the type of the signal that we are using. So it can be a continuous time and the discrete time control system. So continuous time systems are those which are using the continuous signals at each and every stage. But we know that nowadays we are having the controllers which are computer based, and the computer cannot understand the uh, language other than of zeros and ones. So for with computers, we have to use the digital controller or the discrete time controller. So if we are using, so whatever system, whatever control system we are having, they are not purely digital, because when we talk about the plant, that is using the continuous signal. But when we talk about the digital controller or we talk about the computer, it is accepting the digital input. So if we are using discrete or digital input or digital or discrete signal at one or more stage of the system, then that particular system is termed as the digital or discrete time control system. So this classification of the control system is based upon the type of the signal that we are using. So in continuous time control system, all the signals are continuous in time, but in discrete time control system, there exists one or more discrete time signals that we have said, because we are using the digital computer. So obviously at one or more stage, the signal will be discrete or digital. But if we are having discrete signal used at at least one stage of the control system, then it will be called a discrete or digital type of the control system. Then the second classification is on the base of the how many input and how many output we are using. Sometimes we are having a single input and single output control system, like when we are controlling the temperature of an oven. It means that we have to change the input that is being given to the furnace. So that is the current, because it is based upon the, it might be because there are a number of the heating method. Let us consider that it is using the electric, let us consider an electrical heater that is using the heating effect of the electric current. So uh, its input is current and its output is temperature. So there is a single input and single output. So uh, those are called the CISO systems. And in sometimes we have to control a number of variables or a number of uh, things at same time, like within an industry. It might be the case that we are controlling the temperature, we are controlling the humidity, we are controlling the pressure at the same time. And for the control of all these three quantities, we may not be using a single input, like we may be using two or three inputs. So such a system in which we are using multiple inputs and multiple outputs, these are termed as MIMO control systems. So the first classification that we have discussed was the on the type of the signal used, and second is the total number of input and output that we are using. In case we are using single input and single output, it is CISO control system. And when we are using the multiple input, multiple output, these are the MIMO control system. Then Third classification is based upon the linear and non-linear control system. So for that, first of all, we have to understand that what is the meaning of linear. The system is linear. So a control system is linear in case it satisfies the two properties. Means it follows the principle of superposition and follows the principle of homogeneity. Any system, it will be the linear one in case it satisfies these two principles. What is the principle of superposition? Principle of superposition says that in case to other system, if we are giving an input x1 and it is producing output y1, then we are giving the input x2, let it is producing an output y2. Then principle of superposition says that if to the same system we give the input x1 and x1 plus x2, then its output should be y1 plus y2. In case this thing is followed, then we'll say that principle of superposition is followed. Then homogeneity, like the system is such that in case x1 input is given to it and it is producing an output equal to y1, if we multiply the input by k, then the output should also get multiplied by k if the principle of homogeneity is obeyed. Like in case input is k into x1, then output should also be k into y1. So that is the principle of homogeneity. So in case the control system is following both these properties, means in case we are adding the inputs, then the output should also be added. In case we are multiplying the input by a certain value, then the output should also get multiplied by the same value. In case these two principles are followed, then the control system is said to be the linear one. This linearity can also be specified in terms of the differential equation also. In case the differential equation describing the system are such that whatever coefficients they are having, they are constant, then the control system is said to be the linear control system. And moreover, in case you are having the linear relationship between input and output, then we'll say that the system is the linear control system. And in case the system is not following all these things, then the system will be non-linear. Like system is non-linear if it is not following the principle of superposition and homogeneity. Then the system will be non-linear in case the differential equation describing the system has the coefficients which are not constant, which are changing. Then in case the graph between the input and output of the control system that doesn't come out to be a straight line, the system is the non-linear. So the control system can be linear or non-linear depending upon whether these three things, A, B, and C, in case these three principles are obeyed or not. In case these are obeyed, then the system is the linear control system. Otherwise, it is a non-linear control system. Most of the control system that we come across, they are the non-linear control system because non-linearity is everywhere. If we talk about the electronic components, we are having the saturation. Then we are having the non-linear devices, like in case we are using a transistor or we are using a diode within a particular circuit, they are having the non-linear characteristics. They will make up the system as the non-linear ones. So non-linearity is also present in the case of the mechanical circuit, like it is present in the term of the gap between the driver and the driven shaft. Then it is termed as the backlash. It is present in terms of the saturation. There are a number of ways in which the nonlinearity is present in each and every system, almost each and every system around us. So whatever control system that will be making, of course, it is using these components only. So most of the control system that we come across, they'll be termed as the nonlinear control system. But for the purpose of study, we take up a number of system to be the linear time invariant systems. So what are the linear time invariant systems? We have already come to know about the systems which are the linear ones, following the principle of superposition and homogeneity. In case the system is linear, means it is obeying both these principles, then we have to talk about the time invariance. Time invariant systems are those systems whose parameters are not changing with time. Like in case we are having a RLC network and it is used in the same environment today and tomorrow, it will give the same readings because it's a time invariant system whose whose parameters are not changing with respect to the time. So in case we are having a system in which whose parameters are changing as the time is passing, like let us take up the case of an aircraft. So as it is moving towards the sky, then it is using the fuel, and that fuel constitutes a lot of I mean, you can say a significant portion of its mass, and mass is an important parameter of the uh, aircraft. If we talk about the model of the aircraft, then mass constitute a very important parameter. But that parameter is changing with time because fuel is also adding to the mass, and fuel is being used at a very high rate. So when fuel is being utilized, it means that mass is changing with respect to time. So such type of the systems are termed as the time variant systems. So I think you might have understood that what we mean by time invariant and time variant. Time variant are those which are not changing with time, whose parameters are time invariant means that his parameter are not changing with time. And if their parameter are changing with time, then that system is said to be time variant system. Then in case we just talk about LTI system, they are linear as well as time invariant systems. So in the case of the linear time invariant system, the output does not depend on when the input is applied, because the time at which uh, the system parameters are not changing with time. So it means that if we just look at their output, it will be same whether it is taken at this today or tomorrow or the day after tomorrow, as a parameter of the systems are not changing with time. Then we are having the representation. In case we just take up the representation of the linear time invariant system, then they are described by a set of differential equation whose coefficients are constant with respect to the time. It means that the equations describing the LTI system do not change with time. However, input and output variable may change with time. So it means that these properties make LTI system easy to represent and understand graphical, because they are not changing. Their parameters are not changing. So it means that they are easy to represent. Whatever is the system, whatever is the state of the system at present, the same will remain forever. So it become easy for us to analyze such systems. Then we are having time varying systems. So time varying, we have already said that the parameters of time variant system that change with respect to the time. So they are described by the set of the differential equations with time varying coefficients. So these system are described by the equation which change with the time, because the system itself changes. That's why the equations also change. Like we have already discussed about the mass of the aircraft system. It is changing with the time. So there can be other physical properties that may vary with time. So such systems whose parameters change with the time are termed as the time variant systems. Then we are having the causal and non-causal system. Causal system is one whose output depend on the present and the past input. And a non-causal system output depends upon the future inputs. That is, a non-causal system is just the opposite of one that has memory. Like a causal system. In case we are just giving it the input, then it will give the output corresponding to what input we have given and what were its past inputs. So it depends upon its output is depending upon the history. But in a non-causal system, the output is not dependent upon the history. So the non-causal system do not have memory, but a causal system has a memory that depends upon because the output depends upon the present and the past inputs. Then another class of the system that is very important in the case of the control, that are the servo mechanism. So servo mechanism is a feedback control system whose output is a mechanical motion. So if we talk about the servo mechanisms, then we are simply talking about the systems where the variable of concerns are position and its derivative. It means that if we are just concerned about the position, velocity, acceleration, such type of systems will be termed as the servo mechanisms. And in case we are controlling the position, velocity, acceleration, then such type of the systems will be termed as the servo control system. So servo mechanism is a feedback control system whose output is a mechanical motion, as arbitrary disturbances can occur at various points in the system. So a feedback control system must be able to perform its job with the required accuracy in the presence of disturbances also. So servo mechanisms are those where the control variable is either position or derivative of the position. In contrast, we are having the regulating system. So a self-regulating system is simply a system that is having a particular set point, that is the desired set value, and the control system is working in such a way so as to change some input to the process in order to bring it back to the desired set point. Like it can be a air conditioning system, like we have a set temperature. In case there is deviation, we have just set the let us consider we have set the temperature of our AC at 25 degrees Celsius. In case the temperature becomes higher or lower, the system input will change accordingly so as to bring the temperature back to the set one. So in regulating system, we are having a fixed set point, and the control system works to bring the system back to that particular set point. So like the other examples of the regulating system are home hot water system, car cruise control system. A number of other examples of regulating system exist where the set point is fixed. So within these lectures, we have tried to discuss the classification of the control system in a number of ways, on the basis of the signal used, on the basis of the set point, then on the basis of the linearity or non-linearity. So we have come to know that control system can be of various types, but the overall aim of a control system is to make the system behave in the desired way. And that is the most important requirement. So we'll be continuing with this subject in the coming lectures. Thank you.